So next I'm going to go over to Virginia Nicholson, and she's here from the data and analytics team for Google Vision. And she brings both a technical perspective and also a really important, I think, cultural heritage background to Google's visual AI. So thanks for joining us.
Great. Thanks so much for having me. As Tom mentioned, my name is Virginia Nicholson, and I'm currently an engineer within our Google Cloud team. Prior to that, though, I actually worked within our news partnerships team at Google, and previously I worked at the Washington Post for a number of years. So I've kind of lived within the media landscape and now in the cloud and technology landscape for a few years. So I kind of wanted to start at a high level, really regarding how Google thinks about how enterprises and small businesses can leverage AI today. As we've seen, there's been really an explosion of both interest and adoption of AI and machine learning capabilities within large enterprises, and we only see this continuing to grow and grow. Most importantly, though, we see that one of the largest blockers to adoption within the business space is that there's just not enough talent out there. There are not enough machine learning engineers, probably not even enough machine learning developers. So Google is really focused on making it very easy for companies to take advantage of practical AI without having to really fight against these headwinds of not being able to hire enough talent internally. And so this is really a visual description of where we see a lot of the machine learning and AI talent exist today. As you can see, there's kind of this very large set of business users, but the actual number of ML experts and researchers maintains to be very small. And so that's where our product portfolio focus within the AI space is really designed to span this kind of end-to-end solution based on people's skill sets. So we have very robust models that people can develop on their own. You might have heard the phrase like TensorFlow before. That's really geared for people who want to do very custom machine learning work. And then we also have the other end of the spectrum, which is called auto machine learning and AutoML, which we'll get into later, which is really designed to be used for anyone who doesn't need to have a coding background whatsoever. So it's a very user-friendly, kind of sleek front end where it allows you to do a lot of the custom training yourself and really is there to help bridge that gap so that more companies can start to use AI and ML. And if you stop by this afternoon, I can actually walk you through a demo as well. So Google Cloud Vision AI, which I'm really here to talk about today, is really designed to help quickly classify images from a number of different features. And those features are really related to object detection, as well as the boundary boxes of those objects, how to detect if something is safe content versus unsafe content, how to be able to detect emotion on people's faces without doing actual facial recognition, and then also, kind of high-level characteristics of the image, like the overall color composition. So I don't know if we have any baseball fans in the room, but it's a pretty big week for DC. Unfortunately, it's not looking too good on our end, but our first time to the World Series. So I've taken a picture here of a Nationals player, and this is a view of if you were to go to cloud.google.com/vision and just upload any picture, this would actually be the output, or a few of the different views of the output that you'd be able to receive. So in the far upper left, we see kind of the high-level object detections. We see that there's a man, a hat, a baseball glove, some pants, some clothing, as well as a confidence score. If we now go clockwise, so to the right, we can see kind of broader categories that are also assigned to this image. So based on the objects that we've detected, it can also infer that this is actually related to a baseball player, right? It's not just a man who happens to be wearing a glove. We see that there's a baseball uniform, that it's also likely a pitcher. So this is really more contextual information related to the photo itself. If we look at the bottom left, we also are looking at attributes related to the emotion on this man's face. This was when I think the Nats were doing a little bit better, so it said that joy was a little bit likely, and it also is able to detect that he's wearing some type of headgear. You will notice that here we're not actually doing facial recognition. It's not returning anything about the person it is, which I think is an important distinction. And then lastly, which is particularly useful within the image space, is where you can find this image that has been shared on the web. So this is a list of actual web URLs where this image has been found. And that's leveraging a lot of the work from Google Image Search, which many of us know and love. Another area that I wanted to cover in particular was focused on landmark detection, because I know it's particularly important within the publishing space and news space, maybe from a validation perspective, or just to get richer metadata. I know someone mentioned earlier that, over time as you're uploading photos from an archive, you might lose some of this rich information. So in addition to, observing pictures of humans, we also get a lot of places as well. Our landmark detection will able to return exactly which landmark it views. We have a great example online of a picture which looks like it could be the Eiffel Tower, but is actually from the hotel in Las Vegas, which has its own miniature version of the Eiffel Tower. And this is built on top of Google's knowledge graph. So we have about 70,000 different landmarks on the back end, which are help informing this landmark detection, and it will return things like where the location of the landmark actually is. Now, we also get a lot of questions from customers, potentially large enterprises, around, what if I need more specific information from your Vision API that I can't get what we call off the shelf? And that's where AutoML Vision really comes into play. Again, it's very much designed to be accessible by a business user, someone who can upload hundreds or thousands of images which are tagged, and then, with the level of labeling that they want. And then we're able to return a full model, which is accessible via an API. And as someone mentioned earlier, you can either run this within the cloud or at the edge. When I say at the edge, imagine an instance where you're with like Nat Geo or Discovery, and you might have cameras set up to detect different types of wildlife, and those cameras may not be able to be connected to the cloud at all times. You would be able to run these custom models offline on those cameras and still get all of the same benefits of that metadata tagging. So kind of a fun example is, let's say I was a pizza company that was trying to train employees how to top pizzas in the perfect way, right? So I have all these training assets about what a pepperoni pizza should look like, and ultimately I want to be able to inform my pizza creators if they are over topping or under topping, because these have very real business consequences. You're not going to get that type of output from an off-the-shelf Vision API output. It's not going to understand if this is an over-top pizza or an under-top pizza. But in this case, we were able to upload about 60 images tagged with this pizza has too much pepperoni or not enough pepperoni. And then after about half an hour of training, we got a fully accessible model at the end of the day, which could then be put into production, so that if I was the owner of a pizza franchise and wanted to understand if I had certain employees who were overtopping their pizza and costing me a lot in pepperoni costs, I could, investigate that appropriately. So this is just kind of one example of how you could use AutoML in a real-life business application. But again, happy to talk about other ways in which you could use this in your business, no matter how big or small.
Fantastic, thank you. Yeah, and we've, at Gato Images, we've taken, for example, a huge archive where we've digitized it, but we don't have any metadata, and we'll run it through, Google's systems, and we'll get out all of the text if there were handwritten notes on the back of the photo. We'll get out landmarks, like you showed, all these kinds of things that then add to searchability for that content and allow us to kind of find what we're going to put online. So a very powerful capability there, I think.